Earlier we had seen that a current is induced in a coil by changing the magnetic lines of force passing through it. Now let's replace that permanent magnet with a temporary one. Temporary magnet? I hope you remember what a solenoid is. A solenoid is nothing but a long cylindrical coil containing a large number of closed turns. Now how does a solenoid act as a temporary magnet or an electromagnet? Exactly, by allowing current to flow through it. Okay, so now let's see if current gets induced in a nearby coil because of a solenoid. So here comes our setup. Here we have taken two coils, coil 1 with more number of turns and coil 2 with less number of turns. Coil 1, which will act as a temporary magnet, is connected to a battery and a key. And coil 2 is connected with a galvanometer. The idea is to see if current is induced in coil 2 when coil 1 becomes a temporary magnet. To make coil 1 a temporary magnet, we plug in the key and let current pass through it. What did you notice? We saw that the galvanometer was deflected and it instantly jumped back to zero. We'll come back to this point. Now let me ask you something interesting. If we unplug this key, will we see a deflection in the galvanometer? Let's try it out. After we unplugged the key, we saw that the galvanometer got deflected, yes? But in the opposite direction. And after the deflection, it instantly came back to zero. Okay, so what's happening? There was no relative motion between the coils, but still current got induced in the second coil. But how? Let's find out. It was due to a sudden change in current in coil 1. Sudden change? How is that possible? It's because we had given the coil a DC supply. So, when we plugged in the key, current started flowing in coil 1. And when we disconnected it, the current stopped flowing in that coil. In both cases, there was change in current flowing through the coil, which means that the magnetic lines of force around coil 2 also change in both cases. And that's why we see the deflection in both the cases. So how can we understand what happened here? The magnetic field of a conductor induced a current in another conductor. This process is called electromagnetic induction. Here, magnetic field of coil 1 induced current in coil 2. By now, we have learned how to induce current in a coil in two ways. First, by moving the coil towards or away from a magnetic field. And second, by changing the magnetic field around a coil.